Welcome, I am Jayesh Gandhi. We have been talking about flip flops. In today's session, we will be talking about D flip flop. Before we talk about the D flip flop, let us just revise the RS flip flop which we have discussed. The RS flip flop is made up of NOR gate and has three important conditions. 0 input, there is no change. The output retains the previous state. 0 input, the flip flop is set. 1 input, the flip flop is reset. But the most typical condition is the 1 in, where we find that the flip flop goes into a forbidden state and its behavior becomes unpredictable. Because of this unpredictable behavior, the RS flip flop is not used for any application. Therefore, some modifications are required in RS flip flop so that we can eliminate the last condition, that is input 1 1. So as a first step, what we do is we connect the S input directly with the input, and the R input is connected through a NOT gate, and therefore if S is equal to 1, R is 0. If S is equal to 0, R is 1. So if I give the D is equal to 0, the output will be 0. If I give D is equal to 1, then the output will be 1. But then what has happened is that whatever is the input, that has come into the output. And to eliminate the last condition, 1 input condition, we have also eliminated the no change condition. And therefore, this model is not useful. Some modifications, more modifications are made, and we come up with a circuit which is very useful. We have used two AND gate and an additional input called the clock. So if the clock is 0, then the AND gates are disabled, meaning that the output of the AND gates will always be 0, and therefore the RS flip flop goes into a no change state. So if clock is 0, the RS flip flop goes into a no change state. Now we come to the second clock condition, and where if you make the clock is equal to 1, therefore both the gates are enabled, meaning that whatever is the input over here, that will reach the out. So if the input is D, suppose D is equal to 0, then here I will get a 0, here I have a 1, and therefore here I will get a 0. This is 1. The D input is 0, therefore here I will get D bar, and that is 1. So 1 input for AND gate, it gives me a 1 over here, and we can see that a reset signal is passed to the flip flop. The output will be 0. So if clock is 0 and the D value input is 0, then the output will be 0. Now let us come to the next condition. Clock is equal to 1, D is equal to 1, and therefore here I will have a 1, here I will have a 0, and clock is 1, so both these inputs are also 1. So for this gate the output is 1, and for this gate the output is 0, and we are passing a set signal, and therefore the output will be 1, and finally the output over here will be 1. So when the clock is 0, whatever is the value of D, either it is 0 or it is 1, the circuit goes into a no change condition. And when clock is 1, then whatever is the input, that goes to the output. So in presence of the clock signal 1, that means when the clock is 1, the input can be loaded into the flip flop. So if you set the flip flop, a 1 is loaded. If you reset the flip flop, a 0 is loaded. And then when you remove the clock signal, we find that the flip flop will retain the value 1. Let us understand it like this. Let us try and understand the signals with respect to time. So let us assume this is time axis, this is the voltage axis, and I am drawing the clock signal. Let me make it red. The red is clock signal, and then I make it blue. This is the blue value, and this is your data or D input. So initially the clock is 0, and the Q output is also 0, and therefore you find that the no change condition is there. Then the clock becomes 1, and simultaneously the D value also becomes 1, and therefore you will find that a 1 is loaded into this flip flop. This output has become 1 now, and then again the clock is made 0, and therefore the flip flop goes into a no change state, and as a result a 1 is loaded into the flip flop. So in presence of clock, when the clock is present, whatever value I put over here, that goes into the output, and then when I make the clock signal 0, there is no change and the output is retained. So in presence of clock, if I make it 1, that the 1 will be loaded into the flip-flop and it will retain the value 1. It means that if you load a value in the flip-flop and put it into a no change condition, it will retain the value forever till it is changed, and that is exactly the concept of a memory cell. You load a 1 in the flip-flop, take it into the no change condition, the 1 is saved inside the flip-flop. For each memory bit, you will require one flip-flop circuit. So this gives you an idea of what is a memory cell and how a D flip-flop works as a memory cell. I think that brings us to the end of this session, and thank you very much for viewing this video.